Gracias.
No, bienvenido, y pues aquí Monse nos ha organizado esta reunión con mucho ánimo y ya trae más en puerta. Entonces, pues felicidades a todos y Monse en especial por tener esta capacidad de organización y liderazgo y no detenerse ante nada. Entonces, nos beneficia a todos este tipo de eventos. Monse, ¿tú te comunicas con él por vía
correo?
Correo. Pues no, para que le mandes alguno a ver si...
Sí.
Mientras aquí estamos, a ver, voy a poner una pausa. Good morning, everybody, and good morning, Mr. Steve Crocker.
Hi.
Hi, thank you for being with us in Tecnológico de Monterrey in Mexico. I'm going to present. Okay, Mr. Steve Crocker is with us in the class of Networking Fundamentals. And first, thanks to Mr. Crocker for being in class in Tecnológico de Monterrey in Monterrey, Mexico. Thanks to Dr. Joaquín Acevedo, Dean of the School of Engineering in our region. Thanks to Dr. Julio Noriega, Director of the School of Engineering and Science. Thanks to Luis Ricardo Salgado, Director of the Computer Department, North Region. And thanks to Montserrat Cruz, student of the class of Networking Fundamentals, who had the idea and made the coordination to bring Mr. Crocker to the course. And she is also preparing the presentation of Mr. Leonard Kleinrock and Mr. Robert Metcalf. Also, Mr. Binton Cerf was in our course in 2018. Steve Crocker is one of the pioneers of the internet. He worked on the first document that have all the specifications and protocols of the actual internet. RFCs, requests for comments, are known in all over the world, and he made the RFC #1 called host software, and now are more than 8,800 RFCs. All the RFCs are allowed to the public. He's one of the founders of the now called IETF, Internet Engineering Task Force. He worked with Bin Cerf, among others. He has been chairman of the ICANN, Internet Corporation for Assigning Names and Numbers. Welcome, Mr. Crocker.
Thank you. I was playing with trying to set up a virtual background, and my machine is not quite up to it, and now I'm trying to turn that off, and it is making a mess, so I turned off my video. I'll show you, this is what it looks like. If anybody knows how to reset the virtual background, you can let me know. Otherwise, this looks pretty terrible, so I apologize. Anyway, thank you very much. Buenos dias. You have a good group here, and it's a real pleasure to be with you this morning. I guess I'm supposed to look back a long time ago and tell you a little bit about what life was like back in the beginning, which I'm happy to do, and perhaps share some insight as to lessons learned from that period. Might it be possible for me to show a slide or two? Can I share a screen?
Yes, you should do. There is a.
Okay. Let's see if this works.
Okay. Yes.
You can see this, I hope.
Yes.
Yes?
Yes, perfect.
Good. except that one letter is cut off here. I don't know. Oh, never mind. All right. So this won't be a very long set of slides. It's just a quick look back. If you really want to dig deeper, there's plenty of literature and presentations available. I'm going to take you back more than 50 years. And if that seems odd to you, it seems even odder to me to be able to look back that far. The original ARPANET was 4 nodes in the western part of the US, 3 in California and 1 in Utah. Vint Cerf and I and others were graduate students at the University of California, Los Angeles, UCLA, in Los Angeles. We were one of the 4 sites. We were the first site, actually. And the circles represent what you would now call routers. They were called IMPs in those days. And the rectangles were the computers that we had that we all shared. There was no such thing in those days as a personal computer. Computers were relatively big and mostly took up a whole room or had a room devoted to them. We had a Sigma 7. Utah had a digital equipment PDP-10. There was an SDS 940 at SRI and an IBM 360. These were all very different machines. And by different, I don't know how much you pay attention to the insides of machines, but back in those days, there was no such standardization as a byte. Character sets were different. You couldn't translate, or you couldn't just copy a file from one place to another and expect it to look the same. Many of the systems had only uppercase letters and a very few punctuation characters. Sometimes the characters were 6 bits wide, sometimes 7, sometimes 8, and even on some machines 9 bits wide. So I'm just indicating that there was a great deal of diversity, of differences across these several systems. So connecting them together had multiple challenges. Nonetheless, things grew relatively rapidly. This was the first 4 sites at the end of 1969. 6 months later, there was cross-country lines and several sites. And several years later, no longer did we write geographic maps because they were too messy. This was a topographical map. And even this became problematic some years later. This is what the router, or the interface message processor, as we called it, looked like. Today, you can buy this for a few dollars in a store. Usually it's combined with much more complicated functionality like Wi-Fi. Wi-Fi didn't exist at all. It wasn't even quite being dreamed of at the time. This machine cost the US government $100,000 of 1970 money, which would be roughly $500,000 US today, and was very, very small by today's standards. It had 8,000 words, that's 8 kilowords, not megabytes or anything like that. Didn't have any external storage. A very, very simple machine, but it was the first real router that did packets forwarding and routing. That's enough on the hardware. Let me take you into the part that turned out to be not the original focus of attention, but emerged very rapidly as a critical part of the entire system, and indeed where I and others you've heard of, like Vint Cerf, have spent most of our time. A key thing that we worried about was, what are we going to do with this network? We didn't build the routers. We didn't design the packet forwarding, packet switching part of the system. We worked on the part of the higher level protocols. What does one computer say to another in order to accomplish something? And we had kind of an unstructured, open problem in front of us, not very well specified. We knew, of course, that we would want to log in to each other's machines and act as if we had just dialed it up. We knew also that we would like to move a file from one place to another, But more importantly, we understood that these would be just the beginnings, that those would be very simple, and we wanted to lay the foundation for doing other kinds of things. So the representatives from these first four sites got together in a quite informal way, and we began to discuss how we're going to make this happen. And over a short period of time, we evolved, not because we thought hard about it, but it just felt natural, three general principles. One was that the architecture had to be quite open. It had to be possible for people other than us to add new protocols and services. We wanted an architecture for the protocols that would be open and welcoming for new things. We weren't building a closed product that you might find in a store. We were building more of a toolkit that others could build on. The second aspect of openness was that everything we did was available to anybody else for free. The request for comment series was mentioned. As we met over a several month period in 1968 and 1969, anticipating what this network would look like, we started to kick around some ideas. And after a few months, in March of 1969, we said, we better start writing these ideas down. And we didn't view ourselves as being in charge of anything. We just viewed ourselves as contributing to the project. And we assigned ourselves different writing assignments. Several of us sitting around a table in Utah in March 1969. I took on two tasks. One was to write a technical note, and the other was I volunteered for what I thought was a very minor administrative or clerical task of organizing the notes. When I got around to trying to write down what the rules were for what those notes should look like, I found myself feeling quite nervous that the very act of writing down these notes might trigger a backlash, because somebody might come along and say, who are you kids? Well, who put you in charge? You look like you're trying to take over. I used an idea that one of the other people, Bill Duvall, had suggested, and made as just as a matter of form, that every one of these notes would be called a request for comments, as a way of sort of downplaying their importance. I thought it was a very temporary matter that would last for a few months. You can imagine my surprise at how long the RFCs have lasted. But a key point was that not only were these very informal, and we encouraged anybody to write them, but they were available to everybody else, completely open and free. Today, you can still download RFCs from anywhere in the world, and I have encountered some graduate students in other parts of the world who have done very, very big projects using only the information that they've been able to get from loading these RFCs, from downloading these RFCs. A third aspect of openness is that everybody, anybody is allowed to participate. So today, our original little group that we call the Network Working Group has evolved over many years into today's Internet Engineering Task Force, or IETF. And the same principles still hold. There are now a couple thousand people typically participating at any given time. There are mailing lists. We didn't have email in those days, but of course now everybody uses email and other tools. So there are multiple working groups, each one of which is working, and there are a surprisingly large number of active working groups developing new protocols or evolving existing protocols. And the salient point, the critical point, is that participation is open. There's no fees charged to participate. There's no membership requirements. There's no controls. We didn't consciously set out to be different from other standards groups, but in fact, it is quite different from typical other standards groups that are often mediated through government processes where you have to be part of a government delegation to attend, and there are controls on who can get the information. Ours was completely the other way. So those three aspects of openness have made a huge difference, a very, very big difference in the evolution, first of the ARPANET, and then as things evolved into the internet. A critical part of the architecture is that we viewed the protocols as being divided up into different layers. In some of the literature, you can read that there's supposed to be exactly 7 layers. I always consider that to be a peculiar idea, because you can add more things on top, you can put things in the middle, you can dig down below some of the existing protocols and get down to lower layers and build your own things. But irrespective of whether you think there ought to be exactly 7 layers, or there's a variable number of layers, or indeed sometimes it's hard to count them because there are big things and little things at each of these, it's very important that you view these as things that you can build on. And that has made it possible to divide up the work, to evolve the different pieces, and expand quite a bit. Today, these protocol layers are viewed as fitting into what's called an hourglass model, where there's a central layer called IP, which is very, very, very simple. It has, its focus is entirely on moving packets from one place to another across the interconnection of multiple networks. And that's the critical part, that you can have many separate networks. That's what makes the internet an internet as opposed to a single net. And that the only thing that connects them together is an agreement on how to move packets across these multiple networks. Down below are many, many different ways of implementing the physical transport. You have hard wires, you have Wi-Fi, you have many, many different technologies, and these evolve over time. And as long as each new one carries the internet protocol, we're in good shape. And at the same time, right above it are all of the application protocols and other supporting protocols, HTTP for the web, DNS, SMTP for moving mail, and so forth. And these are built on top of TCP, which is it gives you the equivalent of a virtual circuit, and UDP, which is just a slight overlay on top of IP that moves packets from one place to another. And so you have the creation of many, many, many protocols, many more to come on top. And as I say, all glued together by a very, very simple, purposefully simplest possible protocol down below here. I've stressed the openness of the participation in the architecture, and just to make the point, here's a slide I made up several years ago, listing a number of people from outside the US, where a lot of this was born, and the key contributions that they've made. So you have Tim Berners-Lee at the bottom, who is British. You have the invention of Skype in Estonia. I think back in those days, if somebody had said the critical voice application is going to come from Estonia, we would have fallen over laughing, and many of us would have had to go look up where Estonia actually is. eBay, created by an Iranian immigrant to the US. Google, the two founders include a Russian immigrant. So it's been quite an international operation, not just a US operation. Preparing for this talk, I thought, all right, so I'm supposed to talk to a class, and so there should be a lesson here. What would I say about this? So looking back on my own history and thinking about what made a difference and what I might suggest to you all are 3 big things. First of all, find things that you enjoy, become very good at it, and not only that, ask the deeper questions. Ask why things are the way they are, what are the unanswered questions, and so forth. And in doing that, do it in a way that you enjoy it, not just because it's hard work. The second thing, I was fortunate as a kid to be considered to be a very smart child. I had various other problems, but fortunately, I had a pretty facile mind. And one of the things that became clear was that that was not enough. It's nice being smart, but if you don't work hard, nothing gets done, and you wind up on the, left by the wayside. And the third thing is that has really made a big difference is working on problems that both benefit others and that you can cooperate on, things that are bigger than yourself. Some people are quite focused on just doing what is good for their own self, and that's obviously important to a certain extent. But what's made a big difference from my point of view, and I think has been helpful in general in the world, is working on problems outside of one's own direct benefit and working with others. And as I say, working cooperatively with others. There's a certain amount you can do by yourself. You can do quite a bit more when you work with others. That's the end of the formal preparation for this talk. I'm happy to take questions or talk about whatever else you want. Let me turn it back over to you, Professor. I'm not hearing you.
Here I am. Thank you. What would have been happened if you hadn't opened the RFCs?
I'm sorry, can you sit up?
What do you think? What would have been happened if you hadn't opened the standards, the RFCs?
That's a very, yeah, that's a very interesting. What would have happened if we had not created the RFCs? I don't know. It's causing me to think for a minute about that. It's actually part of a slightly different and even larger question of what were the alternatives if we hadn't created the open architecture. I can tell you that, so let me take you back a little bit. When it was decided that the ARPANET was going to be built and the basic design had been laid out, the government put out a request for quotations, a formal bidding process, asking for companies to bid on creating the routers. They did that in July 1968, so we're going back 52 years. At that point, the project was in motion, and within a couple of months, Bolt, Beranek, and Newman had been selected as the contractor, and beginning in right at the beginning of 1969, they began working, and the first first router was delivered to UCLA in September 1969. So from the period from July 1968 to September 1969, the heavy work was done behind the scenes quietly, first in the bidding process and then in the building process. And it had been already determined that what the first 4 sites was going to be, as I said. And then, only then, did someone say, let's get the people at these sites together. So as it happened, Vince Cerf and I, who had been friends in high school and were now sharing an office in graduate school, were among the people who went to this organizational meeting, a first meeting in August of 1968. And there we met people like us from the other sites. And there was not a very careful or tight agenda, but we all understood that this network was coming, that we would have to connect up to it, and that we'd have to make some sense out of what we were going to do with it. We could have focused on the smallest part of the project. How do we move a file from one place to another? How do we simulate the equivalent of a dial-up from one machine to another? But that wasn't where most of us wanted to concentrate. We could see that we could do that. We were all relatively experienced programmers. We'd done a fair amount of programming down in the operating system level, system programming, as we called it in those days. So when we thought about the bigger things, I guess it was a consequence of the fact that we were all in research programs looking at more advanced things, artificial intelligence, computer graphics, robots, and so forth, were the exciting projects of the day. They were all pretty simple compared to what you can do today, but the foundations for these relatively advanced ideas were being pursued in the laboratories that we were working in. So we took the view that connecting these computers was going to enable not just the simple things, but also the more complex things. And that led us down a path, as I've said, of trying to build these open protocols and make it possible for others to do things later. So the question you're asking, if we hadn't created the RFCs, I think is really part of a bigger question of what would happen, what would have happened if we had taken a much narrower approach toward what we were trying to do. So that's how we set off. Over the next couple of months, next several months, we tried to design a general basis for the protocols. And I actually had a moment in which I didn't think we were going to be able to do this. It was looking too hard and it was taking too long. And I actually suggested to Larry Roberts, who was the top guy. He was running the office in Washington that funded and designed the network. And I was quite nervous that he would be unhappy that we weren't making more progress. And I suggested that we could pull back and just do simple things. And I was pleasantly surprised when he said, no, go after the harder problem, keep working on it. Later, I had the privilege of actually going to work for him in Washington and sitting on the government side of funding projects around the country, an enormously thrilling educational experience. I got a front row seat on all of the best research that was going on. But I think to come back to your question, if we hadn't taken that general approach, I don't really know what would have happened, because on the one hand, it would have been a much more modest effort. And on the other hand, the pressures to use the network for interesting things, for voice over IP, is what you call it now. We didn't have the same terminology, but sending voice over a packet switch system was indeed one of the very early experiments. How to move graphics around, all of that would have been pushed ahead in one fashion or another. It would have looked different, but I don't think it would have been stopped. In some ways it would have been messier. In many ways, the way it's actually emerged has been messy and chaotic in its own way. So it's a little hard for me to say, but I like the question very much. Thank you.
Thank you. Luis Daniel Vasquez, are you there? You want to make a question?
Yes, I want to make a question. First of all, Steve, thank you so much for taking the time to make this presentation. It's really neat to have all the insights that you gave us while you were building literally the internet. So my name is Luis Daniel, and my question, kind of on that same path, is: did you ever imagine when you were like doing this project, like becoming this huge thing as the internet? And kind of like a follow-up question on that. And did you think that it will get to the point that is right now with 5G, that we have like download of like gigabyte per second and like 1 second of ping? Did you ever imagine getting to that specific point, or it just kind of rapidly grew to that point? Thank you.
Thank you. So as you can imagine, I get asked some form of that question fairly often. Sometimes it's asked in a more hesitating way. Could you, did you, could you have imagined, etc. And I usually answer, everything is proceeding exactly on schedule, which is indeed a joke. Let me give a serious answer. We knew that we were doing important things. We knew that it was going to have a big impact. Personally, I viewed it as a distraction from doing serious research. I had in mind focusing my attentions in other areas. I was quite interested in artificial intelligence and understanding how the mind works. And I viewed the network as just a straightforward engineering. I could see that it would have very big impact, but I didn't think it was very deep from an intellectual point of view. I was wrong about that. There are plenty of very hard, intellectually challenging questions, but I was young, and that's was my view. But I did see that it was, as I said, that it was going to have a huge impact, and that in very, very short order, everybody who had a computer, and remember back in those days, a computer was a big thing. There was no such things as personal computers. Smartphones that we all carry in our pocket were fantasy. They were science fiction. They were Dick Tracy who carried something on his wrist. It actually wasn't as smart as today's smartphone. But that was all fantasy. But everybody who had a computer, and by everybody I'm talking about businesses, governments, and universities that didn't have them in high schools, didn't have them at home, would want their computer to be connected to the network. That was clear almost instantly, because the power of being able to move files and talk to people and collaborate was enormous, and you could just feel it. So that part, I think all of us saw to some extent, some more, some of us saw more pieces of it than others. I can tell you personally, the parts I didn't see, I didn't anticipate Google. I did see that you could have commerce on the network. As I say, but I didn't anticipate the effect of Google quite as much as it turned out to be. And the social media was just not something I paid any attention to. We had in the very early days the ability to see who was on another computer and to set up a chat session with them, and we could see we were roughly your age. We were in our 20s, so social interaction was important, particularly since it was a male-dominated world. The few women that were around got lots and lots and lots of attention. And we kept track a little bit of what relationships emerged from this community that was first hundreds and then thousands, but not yet millions of people. So we could see a good portion of what was coming. Money, the cost of machines was very important in this story. If you've heard of Moore's Law, it documents the dramatic change in the amount of computer power that you get over time. And an easy and pretty good approximation is a factor of 10 every 5 years improvement. So for the same money, you get 10 times as much computing power every 5 years. Now you take 5 years and extend it to 50 years. Well, let me shorten that. Extend it just to 30 years, and now that's 6 powers of 10. That is a millionfold. Well, that's enormous, because we had experiments in laboratories with graphics. We had experiments with at early days with voice and so forth. The idea of having a conversation like we're having right now, and particularly that you could just, you know, depend upon it, that you don't have to run careful tests and, you know, it all work. We could imagine, but we couldn't do it. But we could do early versions of this. So the transition from laboratory experiments to it's available to everybody without thinking about it is really one of the more dramatic things that's taken place over this long period of time. But we did actually have a window. We could see that in the future, all of this should be possible. And that was enormously thrilling to be able to see that far into the future and then patiently or impatiently wait for it to happen.
Yes. Awesome. Thank you.
Kevin Bojorquez.
Hello, Mr. Crocker. It's an absolute honor having you here. I'm Kevin Bojorquez, and my question is, how do you ensure that the IETF stays as decentralized as possible and keep a truly open participation in the future?
Yeah, it is one of the constant problems in all of the structures that we build. It was mentioned that I've been involved with not only the IETF, but with ICANN. ICANN is a organization that oversees the top level of the domain name system and allocation of address space and other matters. And a very, very important point for the IETF, for ICANN, and for the other parts of this whole ecological system are the governance aspects. And the only way that we can ensure that things remain open, that the processes remain relevant and effective, is active participation by people who have the right sensibilities, the right ideas about this, and participate. So let me urge all of you to take a look at the organizations that are involved. Some are global, like IETF and ICANN. Some are local. The Internet Society has chapters everywhere. Participate in those. And get involved, understand what they're about, and see to what extent you think you can make a contribution to either the substance of what their topics are or to the organizational and governance structure. I gravitate toward the substance aspects, but as a matter of necessity, each of us has to pay attention to the governance aspects. And those two things should fit together. Governance by itself is meaningless if there isn't any substance, and substance by itself doesn't hold together unless there's at least a certain degree of governance. But get involved, take a look. One of the really, really important aspects is that the internet itself, because it provides all of this connectivity, provides access into the governance structures, so that the decisions should be visible, the people who are making the decisions should be accessible, and each of you has a voice, and don't hesitate to use it.
Okay, thank you. Mauricio Garza Martinez.
Hi, Mr. Crocker. Thank you for coming to our class. Well, my question is, what do you wish you have done differently with when the RFCs were created?
Well, there's a good question. What do I think we've done differently? I mentioned that my focus of attention was originally different, and artificial intelligence and how the mind works. And one particular topic which has remained on my mind is proof of correctness of software capturing the reasoning process when software is built. And when we started to design the protocols, I thought maybe this would be an opportunity to use those kind of formal methods, as is now called, to make sure that the protocols worked properly. That has not worked out as well as I would have liked. The documentation on the protocols is pretty good, but it could be better. We didn't specify timing constraints very well. That has both good and bad aspects. The good aspect is that the timing aspects of internet protocols is fairly loose, and things work because of that looseness. But on the other hand, if you exceed certain limits, things start to fall apart. To take a very extreme example, you can't really run TCP from here to Mars because it's too far, and the retransmission times and everything would be completely unreasonable. And that's led to the creation of actually special purpose protocols for operating in space. But the documentation of the protocols has not paid close attention to an analysis of the timing. And also the corner cases. What happens if somebody does something a little bit different than what's expected? Sometimes causes some glitches. So I would have preferred a slightly more formal specification and more rigorous analysis. That slows things down. The techniques for doing that are not even now well worked out. And there was just enormous and remains enormous pressure to build things and get them working pretty well. And that's what's dominated the process. But that's what I had in mind anyway, as part of the protocol process.
Okay.
Okay, thank you.
Abraham Collins wants to make a question.
Hi, my name is Abraham Collins. Nice to meet you, sir. My question is, which of today's technologies do you think or are more interesting to you, or that you see, I don't know, more promising?
Oh my! Which choices do I have to choose from? What technologies are you thinking about?
Well, I think I was thinking of more as a general question, and precisely so that you could answer like in what you like the first technologies you think about. But
Well, okay. One of the most important things that has been happening over the last many years and will continue is the interface of computers and networks to the real world, to physical devices and to other technologies. So I'll just name a couple. You have, of course, the enormous spread of the Internet of Things, as it's called, which are really small devices that act as sensors in various places and report information. You also have the fairly rapid development along the biological sciences, interfacing computing with the human body, with other processes and so forth. You now have devices that you can wear that are sampling what's going on inside the body. I think this is going to have a huge impact on medicine and on maintenance of health, as well as larger issues like detecting early detection of epidemics and other kinds of things. Along a different dimension, as we all know, robots have come along from early toys and bad experiments to now where we have self-driving cars and other kinds of things. We're at the very early stages of seeing what that impact is. a different, related but different, is the engagement with mostly visual with the real world, understanding what you're looking at, understanding to some extent what you're hearing. We're close to having devices that participate actively. I could imagine, just to make something up on the spot, that you can have some software which is participating in this very conversation and attempts to ask an interesting question after listening to this. And that question might be humorous, or it might be even deeper than some of the questions that we're asking here today. So there's many different directions. It's become quite an expansive, very, very broad field, does not have a single direction. And so you can pick out almost anything, and it will likely emerge as a major and important topic in its own right, creating jobs in the whole industry and many, many interesting possibilities.
Thank you.
Thank you. Miguel Novak, want to make a question?
First of all, good morning, Mr. Crocker. Thank you so much for sharing your time with us. So I have two questions, but I can only ask one. So do you prefer the personal question or like a more technical question?
Up to you.
Okay, I will ask the personal question. Do you use a VPN for personal use in your life?
Do I use a VPN? I do use a VPN. I don't do it as often and as carefully as I should. I have the mechanisms, and it's an actually interesting question. My son is an attorney, works for the Electronic Frontier Foundation, and he is constantly on my case about protecting my machines. I tend to be a little less concerned. Fortunately, I have not had any bad experiences. Do not take this as an invitation to cause me to have a bad experience, please. But I do have VPN accounts. Today, none of us are traveling, but I have traveled in quite a large number of places around the world. And if I'm in a hotel room or otherwise unprotected network, I would tend to use a VPN. But in principle, I ought to be using a VPN all the time.
Thank you.
Okay. Mauricio Sanchez.
Hello, Mr. Crocker. Thank you for being here. And my question is related about the future of the networks. For example, you know about the 5G internet. My question is related about if you think that in the future the internet standards will change, or you think that will be always like the like in this time.
It's what's going to happen with internet protocols and standards in the future, I think, is what you're asking. It's a little hard to say, but also I think that there are actually a few different questions that are all part of the same large picture, but have different answers. There's quite a bit of attention to trying to so-called regulate the internet. And when one listens to those discussions more carefully, a lot of the issues are regulating the content, which from the point of view of those of us who built the internet, we don't think of that as part of the internet. We think of those as applications that run on top of the internet. But of course, for the very, very large majority of people who use the internet, it's all part of the same thing. So the questions of how do you regulate hate speech? How do you eliminate fraud? How do you protect the end systems from being penetrated by pirates or others? are questions of national importance and international importance, and that is leading, has led various countries to try to impose restrictions on what can travel over the internet. You have a great firewall of China as a major example, but certainly not the only one. And I think every country to some extent is concerned about those things. I think the base level protocols are going to continue to be developed, I hope, within the IETF and the closely related organizations. But even there, there are efforts to suggest that there ought to be a complete change to the basic protocol structure. I think my personal view is that those efforts are motivated more by political concerns and less by proper technical analysis. But one never knows what happens when governments get involved from a political point of view. So I would hope that everyone takes a look at these things very carefully and separates out the technical aspects from the political aspects, and otherwise we're in some danger. The good news, I think, is that the internet has been such a huge success that it's very hard to displace it and very hard to replace it all at once, and so it's going to be a kind of an evolutionary matter.
Thank you.
Okay, thank you for your time, Mr. Crocker. Julio or Ricardo wants to say something.
Well, just thank you very much, Steve Crocker, for being here in this class. It's really inspiring to hear someone who has been involved in a technology and the development of technology like the internet, and to see the views and the values behind what you build. These three elements of the network, but as well of your point of view about how to build and cooperate with others are really clear and lay the foundations for how things can help to the world. And having the time to meet our class with these students in the very good point of the time to think about the future and how they contribute, it's really an important thing for us. Congratulations for what you have done as an engineering, as a leader in the technology in the world, and thank you for being here. And also Rafael and the lady who made possible this link with Steve Crocker, thank you very much for your invitation.
Well, thank you very much for the invitation. It's been a real pleasure, and I wish you all great success. You're in an area that has an enormous set of opportunities, and so I think the future is very bright for all of you.
Thank you. Ricardo, are you there?
Yes. Well, as Julio says, it's has been a really nice opportunity to meet with you. Thank you so much. I think this is a very inspiring talk about the possibilities, your point of view from that time, and what our students are able to do in the future. So thank you so much. Congratulations for your work, and thank you for that effort and this continuous life of pushing hard in technology. Thank you so much.
Good.
Thank you.
Thank you.
Thank you, Mr. Crocker. Julio Noriega is the director of the engineering school here in Tech, and Ricardo is the director of the computer department. And we also want to thank you for your time. All appreciate all the effort that you have made to the technological approach here in the internet development of the internet. Thank all the humanity appreciates your work.
Thank you. All right. So with that, I think I've used up my time, and I'll withdraw unless there's something further. And thank you again for the invitation.
Bye-bye, Steve.
Okay.
Thank you. Bye-bye.
Thank you, Dr. Crocker, for being here.
Thank you.
Thank you very much.
Mr. Crocker.
Bye-bye.
Thank you. Vamos a cortar la sesión y abrir otra para continuar la clase de fundamentos de redes. Gracias a todos los que se conectaron. Avisos. Monse está organizando otra reunión con otro de los fundadores del Internet, el padre del packet switching, Leonard Kleinrock, y está organizando otra reunión con el creador de las redes Ethernet, Robert Metcalf. Entonces, pues traemos todavía muchas noticias por aquí para que nos puedan seguir acompañando. Gracias a todos. Y ahorita conéctense otra vez los alumnos de Fundamentos de Redes. Y los de seguridad nos vemos a las 10. Adiós y gracias.
Gracias, Rafa. Felicidades.
Gracias.
Gracias, Monse.
Gracias a todos.
Gracias.
Bye-bye.
Gracias, buen día.